We'll learn about Next.js 15 caching and rendering using the app router in this full course. You'll gain a clear engineering level understanding of how Next.js optimizes web performance through advanced rendering strategies and layered caching. This course covers the different rendering methods, which are SSG, SSR, ISR, and CSR. And you'll learn how React client and server components work together, including a look at the React server component Payload. The course features real-life examples that demonstrate how caching strategies are applied in modern Next.js applications. This course will help you leverage Next.js caching to build faster, more efficient web apps. Sumit Saha created this course.
If you are a Next.js developer in 2025, what exactly should you be focusing on right now? Because let's face it, ChatGPT can write the code for you. Your real job? You are the one who makes the architectural decisions. You are the one who sees the entire application from a bird's eye view, like an eagle in the sky. And whenever the ChatGPT gets stuck or does something wrong, you swoop in like that eagle and fix the problem. That's why you absolutely need to understand how the entire Next.js framework works under the hood. And when it comes to that, there are two core things you must master: rendering and caching. Honestly, I can confidently say most people don't understand these two things properly. That's exactly why many developers say Next.js is too complex, too many bugs, not really developer friendly, and so on. Let me tell you, that's completely false. The real reason is Next.js is smart. It's just so smart that a lot of people can't keep up with it. And instead of learning how to cope with that smartness, they blame Next.js and walk away. But after watching today's video, I promise you will understand how Next.js handles caching and rendering like a pro. So, well, in fact, that you just might fall in love with Next.js. And who knows, maybe you will even start building all your future projects with it. Alright, without wasting any more time, let's dive into today's video. Before we dive into caching in Next.js, let's first understand what is caching, really. Imagine you go to your favorite restaurant and place an order. The first time you do, the chef takes a bit of time to cook and serve the food. But if many people keep ordering the same item again and again, the restaurant starts preparing those dishes in advance. So next time someone orders it, they can serve it immediately. That's caching. Preparing and storing something ahead of time, so it can be delivered quickly when needed. The same thing happens in web development. Instead of generating a page from scratch every single time, we store pre-generated versions so visitors can get them instantly, making the website much faster. Now that we have understood caching in a simple way, let's start exploring how caching works in the context of Next.js. To really grasp caching in Next.js, we first need to understand its different rendering strategies, like static site generation or SSG, server-side rendering or SSR, incremental static regeneration or ISR, and client-side rendering or CSR. Why? Because when data is fetched, when the page is generated, and how long the data or page is stored in cache, all of that varies based on the strategy used. So, to fully understand how caching works in Next.js, you must first get a solid understanding of when, where, and how each rendering strategy is applied. Let's begin with static site generation or SSG. SSG is a process where your site's pages are generated ahead of time, right when you run the build command. If we go back to our restaurant analogy, think of it like this. There are a few dishes that everyone always orders. So the chef prepares those in advance. As soon as someone orders one, it's ready to go, served immediately. That's how SSG works. The pages are already pre-rendered, so when a user visits the site, they see the page instantly without any extra work. This leads to a high performance and low server load. The only job at runtime is to fetch the pre-built page from the server and show it. SSG's biggest advantage is performance, but it has a limitation. Since the pages are only generated once during the build time, if your content changes frequently, like user-specific info, live data, or real-time updates, the SSG isn't enough. Let's say someone walks into the restaurant and orders a dish that hasn't been prepared beforehand, or whose ingredients keep changing all the time. The pre-cooked version won't work. It has to be made fresh on the spot. In these kinds of situation, we need SSR. With server-side rendering, the server generates the page every time a user sends a request. So users always get the most up-to-date content. The downside of SSR? Performance. Because now instead of the developer generating the page during build time, like with SSG, the server has to generate the page again and again for every single visitor. That means slower load times and higher server stress, especially under the heavy traffic. To balance out the pros and cons of SSG and SSR, Next.js offers a clever solution called Incremental Static Regeneration or ISR. It's a hybrid strategy that combines the best of both worlds: SSG's pre-building and SSR's fresh content. Let's go back to our restaurant again. Say there are dishes that people order frequently, so you pre-cook them just like in SSG, but if no one orders them for a long time, they might go stale or cold. So you decide, I will refresh those dishes every X minutes so they're always fresh. But until then, customers will still be served the old one. And meanwhile, the kitchen will cook a new version in the background. Once the new batch is ready, the next customer gets the updated dish. That's exactly what ISR does in Next.js. You pre-generate the page just like SSG, but you also define a time interval after which the page will regenerate it in the background. So you get the performance of SSG and the freshness of SSR. The perfect balance, right? Now that we have talked about SSG, SSR and ISR, let's move on to another strategy. One you will often see in single page applications or SPS. That's client-side rendering or CSR. Imagine walking into a live kitchen and placing an order. But instead of a chef preparing the dish for you, all the ingredients are delivered to your table and you cook the meal yourself. That's CSR. In CSR, the entire JavaScript bundle is loaded in the browser. So when a user navigates to a page, no new HTML is fetched from the server. Once necessary, data is fetched and the browser builds the page using JavaScript right on the client side. So essentially, the cooking happens in the browser. You fetch the ingredients, that means the data, and your browser does the rest. CSR works well in highly interactive apps like dashboards, where data changes based on user actions, etc. However, since everything needs to be loaded in the browser upfront, the initial load can be slow. And from an SEO perspective, it has some drawbacks too, because search engines often struggle to crawl JavaScript-heavy pages properly. So now we have explored all of Next.js' different rendering strategies. But before we go deep into caching in Next.js, there's one more crucial concept we need to understand. And that is the difference between React client components, server components, and also something called the React Server Component Payload or RSC Payload. Let's dive into those next. Let's begin by first understanding what client components and server components actually are. But to do that, we need to briefly understand how a web page is rendered on both the server and the client. Whenever you hit a URL from your browser, the server receives that request and sends back a response. But how is that response generated? When you request a page, certain operations happen on the server. The server might be running PHP, Python, Java, or JavaScript. Basically, any server-side language. It processes the request, fetches data from a database or from some external API, and finally generates a web page, which is ultimately just an HTML page. For example, Laravel uses its Blade template engine to generate a designed page using HTML and CSS, renders that on the server, and sends it as the response. This response contains HTML and CSS. Along with that, some JavaScript is also sent to make the web page interactive. Remember, the interactivity doesn't happen on the server. It only happens once the page is loaded in the browser. So the HTML and CSS come as part of the response, and separately the JavaScript bundle also gets sent. Once all three, HTML, CSS, and JavaScript, arrive in the browser, that's when you see a fully interactive web page. However, the JavaScript bundle might take a little time to load. And until that JavaScript finishes loading, your designed web page may not be interactive. For instance, imagine your page has a button that's supposed to do something when clicked. But that click event won't work until the JavaScript bundle has fully loaded on the client. And once it does, suddenly your design page becomes interactive. This process is called hydration. That's the basic idea of how a typical web page is rendered. And one thing we can already infer from this is the faster your web page will load, the smaller your JavaScript bundle is. Right? Now let's talk about how rendering works in React or Next.js. If you are working with a website or web application built using React or Next.js, the programming language working on the server side is JavaScript. More specifically, Node.js. That means in React or Next.js apps, all rendering on the server is handled using JavaScript. So when a request comes into a React or Next.js app, Node.js does the server-side work, like fetching data from APIs or database, and then generate the HTML. As you already know, in React apps, we build small reusable components using JSX. On the server, all these components together form a React tree. Now, in that React tree, some components may contain interactivity, like a button you can click or a slider that moves. These interactive components are called client components because they only work on the client or browser. They don't do anything on the server. On the other hand, there are components that simply display data or generate HTML or CSS and don't require any interactivity. These are called server components because they can be rendered directly on the server and don't need to be downloaded to the client. When the React tree is rendered on the server, we end up with HTML generated from our JSX. But here's the catch. Client components must still be sent to the browser because they need to run there. Rendering them on the server wouldn't make any sense. So when Next.js is rendering the React tree on the server, it scans through the tree and figures out which components are server components and renders only those. And when it encounters a client component, it doesn't render it. Instead, it just leaves a blank placeholder there. It basically tells the browser, hey, I am leaving this spot blank. You go ahead and render this when it gets to the client. That means for any web page request in a Next.js app, the server sends back a response that contains number 1, the rendered HTML, number 2, CSS, number 3, the JavaScript required to hydrate the client components. This is the usual JS you need for interactivity. And number 4, if needed, parts of the React or Next.js libraries. Because otherwise, who would take the JSX and turn it into HTML inside the browser? But here's the issue. React and Next.js are both huge packages. Sending the entire React and Next.js bundles to the browser just to render some components would be extremely inefficient. So what has Next.js done to solve this? Well, it's smart. It knows that it already rendered about 80% of the components on the server components. That HTML is already sent to the browser and showing up fine. So to avoid sending the entire React and Next.js libraries, it sends just a tiny file, a smart, compact piece of data that helps the browser reconstruct the full React tree without React or Next.js. That little file is called React Server Component Payload or simply RSC Payload. When the server components are rendered on the server and HTML is generated, this RSC payload is also created. What does it contain? It's like a logbook written in a very specific format. It contains all the key details, like which components is a child of which one is the parent, their internal relationships, and so on. So the client can use that to rebuild the full React tree even without reading React or Next.js. Also, if a server component is passing any props down to a client, those props are also written into this tiny logbook. This RSC payload is then sent along with the server response. Once it reaches the client, the browser can use this RSC payload to regenerate the tree. And since all the information is already there, it doesn't need to download the full React or Next.js libraries. Inside the Next package that we install, there are both server and client parts, all written in JavaScript. Same for React 19. It now has both client and server parts inside the same library, also JavaScript. If the browser had to download all of that just to rebuild the React tree, imagine how huge the JavaScript bundle would get. But thanks to the React server component payload, this small efficient log file, the whole process becomes super optimized. Now, in the browser, only the small client part of the React library is loaded, just enough to render the client components and use the RSC payload to connect everything together and build the full tree. Same with Next.js. Only the small client-side JS is downloaded, like the tiny bits needed for routing or page transitions, the logbook that Next.js wrote on the server during the server component rendering also comes along the response. It's not quite JSON, but it looks like a serializable format, and this is what we call the React server component payload, the RSC payload. So, to summarize, whenever a client requests a page from a Next.js app, the server components are rendered on the server. The client components are left as placeholders. A small log of how the full React tree was built is created. This is the RSC payload. The client receives number 1 HTML, number 2 CSS, minimal JavaScript needed to hydrate the client components, only the client-side parts of React and Next.js library, and the RSC payload. This helps keep the JavaScript bundle size super small. I hope now you clearly understand what server components are, what client components are, how the rendering process works in React or Next.js, and most importantly, what this RSC payload is and why it's so powerful. Now that we understand how rendering works in Next.js, including the different rendering strategies, client and server components, and the RSC payload, it's finally going to be much easier for us to understand Next.js caching flow. But to really get a solid grasp of how caching works in Next.js, we need to start by asking ourselves very few important questions. And while we explore the answers to those questions, we will naturally uncover how the entire caching system in Next.js actually works. So let's begin. First, imagine a user makes a request from their browser. They are trying to access a specific page or some data from the server. Now here's the first question. Does that request actually need to go to the server at all? Because think about it. What if the user's desired page or data is already cached inside the browser? In that case, we don't even need to hit the server, right? Okay, fine. Let's say the request does go to the server. Next question, does the server really need to render the page again? Because if the server already rendered that page earlier and stored it somewhere, maybe we can just reuse it. So again, no need to re-render. Now, let's assume the page was not pre-rendered. So yes, we do need to render it on the server. But now the question is, to render this page, do we really need to fetch new data from the database or an API again? What if we had fetched that same data earlier and the response was already saved or cached? Couldn't we just reuse it and avoid making an extra network call? And if we really do need to fetch the data again, here's one final question. Do we absolutely have to hit the data source again to get fresh data? Or maybe the data is already cached somewhere on the server side and we could just use that to render the page? I know this may all sound a little confusing at first, but here's the thing. These confusing little questions, they actually hold the key to understanding Next.js' most powerful caching strategies. As we explore the answers one by one, you will see the entire Next.js caching system become super clear and easy to grasp. Alright, as we go through these questions together, let's also explore the different caching strategies that Next.js uses. Now, typically what happens is, we send a request from our browser to the Next.js server, and the server sends back a page in response. But along this journey, there are some really important questions that Next.js asks internally. And if we follow these questions, we will actually start to understand how each of these caching strategies work. Let's begin with the first point in that journey. Whenever the browser sends a request to the server, the very first question Next.js asks itself is, do I even need to go to the server? Or is the content of this page already loaded in the browser? Maybe the user has already visited this page and it's stored somewhere. That's the first caching layer, and the strategy Next.js uses to answer that question is called router cache. Now, this cache exists entirely on the client side, inside the browser. That means there's no need to even hit the server if the page is already stored in memory. Let's say I have visited a page before. Next.js stores that page content in the router's in-memory cache on the browser. So, if I navigate to the same page again, I get the page directly from that memory cache without making a new server request at all. Cool, right? Now, let's move on to the next step. Let's say the answer to that first question was yes, meaning the root wasn't found in the browser's in-memory cache. So now we do have to go to the server. But once we are already on the server, the next question is, what do we do now? Well, our job is to render the React tree. Basically, generate the entire page and send it back to the client. But here comes another important question. Do you really need to render it from scratch every single time? Because rendering also comes with a performance cost, right? Now imagine a situation where the exact same page was already requested and rendered before by another user. In that case, does it really make sense to render it all over again? Probably not. And that's where Next.js asks another caching layer for help. This one is called full root cache. Here's how it works. On the server side, when Next.js detects that a certain page might get rendered frequently, it caches the full rendered version of that page to make things faster. So next time someone requests the same page, Next.js doesn't have to render it again from scratch. It just serves the cached version instantly. That entire process is known as full root caching. Clear now? Now imagine the answer to that last question was yes. Meaning, yes, we do need to render the React components. Why? Because this page hasn't been pre-rendered or generated on the server yet. So, at this point, rendering begins and we dive deep into the React tree. Inside this tree, different components may be performing data fetching. Some might be using the fetch API and others might be querying a database directly. Now here comes the next question. Do you really need to perform all these fetch requests? Or is there a chance the result of these requests are already cached? This time, Next.js turns to a different caching strategy for the answer, and it's called request memoization. So, what does this strategy actually do? Let's say you have a page with 5 React components. They are nested, parent-child style, and maybe 3 of them are doing data fetching. Now here's the thing. If 2 or more of those components are making similar or identical requests, then there's no point hitting the server over and over again for the same data, right? Instead, Next.js will remember the result of the first fetch and reuse that result for the other components. That's exactly what request memoization does. It keeps track of previously made fetch requests and their responses. So, Next.js basically asks the request memoization cache layer, hey, do you already have the result for this request? If yes, just give it to me right now. If not, I will go ahead and make the request from scratch. And if the answer is no, meaning it's a cache miss, then yes, Next.js has no choice but to hit the server, query the database, or call an external API to fetch fresh data. Now, here comes another super important question. Does Next.js immediately hit the database or external API? Or does it check one more time before doing that? Just to be sure the network call or query is even necessary. Well, Next.js asks this question to yet another caching layer, and it's called data cache. So what does data cache do? Let's say a piece of data was already fetched earlier, and the result of that fetch was stored or memoized somewhere on the server. Now, if we request that same exact data again, there's really no need to make another API call or database query, right? We can just reuse the cached result. And that's exactly what the data cache handles. At this point, Next.js goes to the data cache and asks, hey, do you already have the result of this query or API call? If the answer is yes, then boom, the cached result is returned directly. This boosts performance a lot. No need for another fetch. But if the answer is no, meaning it's a data cache miss, then Next.js has no choice but to go to the original data source, maybe a MySQL database, MongoDB, or an external API, and fetch fresh data from there. Once the data is fetched, Next.js then saves that result back into the data cache, so that next time if someone asks for the same data, it doesn't have to hit the source again. I hope by now you have got a clear picture of how this entire flow works. Now, based on this same flow, we are going to break down each caching strategy in Next.js one by one. And I am going to explain them in the exact logical order that Next.js uses when handling caching internally. Request memoization, number 1. Number 2, data cache. Number 3, full root cache. And number 4, client-side router cache. Now, this order isn't just the easiest to understand. It's also the exact structure that the official Next.js caching documentation follows. So yes, I have designed this video based on the official docs to make sure you are learning the correct modern caching flow that Next.js actually uses behind the scenes. And here's the cool part. If you watch this video and later check out the official docs, you will find everything much easier to read, and the whole caching ecosystem will feel crystal clear to you. Now that we have learned the names of the 4 caching strategies in Next.js, it's time to dive into each one in detail. But before we do that, we need to first understand something called the 3W and 3H framework. So what is the 3W and 3H framework? This is a simple but powerful mental model that helps us break down any caching strategy in a structured way. According to this framework, we need to ask 3 questions starting with W and 3 more starting with H. Let's begin with the W questions. Number 1, what is the strategy? In other words, what type of caching are we using? Is it memory cache, file system cache, external CDN cache, or maybe database level caching? Number 2, where is the cache stored? Where exactly is the cache data being stored? On the local file system, in the RAM, in Redis, or in a third-party storage service like S3 bucket or a CDN? Number 3, why caching? Or what's the benefit of this strategy? What do we gain by using this strategy? Is it better speed, optimized resources, reduce server costs, or maybe an architectural advantage? Now let's move on to the H questions. How long is the cache valid? This is also called the cache duration. For how long will the cache data remain valid? Is it for a few seconds, a few minutes, hours, or maybe indefinitely? Number 5, how to refresh or revalidate the cache. This is what we call cache revalidation. If the cache data becomes outdated, how can we refresh or revalidate it to ensure the user sees the most up-to-date data content? Number 6, how to ignore, opt out, or invalidate this caching strategy. If in a certain situation or for a specific request, we want to bypass the cache, how do we do that? How can we manually skip or invalidate the cache? Now here's the important part. Whenever you are designing any kind of caching system, whether it's for a small project or a massive enterprise architecture, you must follow this framework and try to answer these 6 questions. And guess what? Next.js also built their caching system by following this exact same thought process. Alright, that was enough theory for now. Let's now jump into some real code examples, and as we go, we will try to answer these 6 key questions for each caching strategy. That way, not only we will understand them conceptually, but we will also see exactly how they behave in practice. And by the end, you will have a crystal clear understanding of how each caching strategy in Next.js actually works. Alright, let's not wait any longer. Let's jump into the first strategy, request memoization. Before we dive into request memoization, let me quickly show you my setup. Because we will be using this same setup for explaining each of the upcoming caching strategies, and I will be showing a separate example for each one. This is a simple Next.js application. If I open it in the code editor, you will see nothing fancy here, just a basic boilerplate structure of Next.js. But there's one important thing I want to highlight. As you can see, there's a separate folder here named server. This is a mock external server that I have created myself. Why? Because I want full control over the API and the server. I should be able to modify the data whenever I want so that I can demonstrate live how caching actually works. I didn't use a remote API like JSON placeholder because you can't change the data there. But here, since I have built my own mock server, we will be able to see in real time how cache hits and misses happen. So now, if you have never heard of JSON server before, let me tell you, it's a widely used and very popular package. It's mainly used to create mock REST APIs. And for front-end developers, it's just perfect. All you have to do is run the command npm install JSON server and point it to a .json file that contains your data. Then, based on that file, JSON server will automatically generate REST API endpoints for you. If you didn't catch all of that, let me quickly summarize it for you. Inside our mock server, if you go into the package.json file, you will see that I have only added one dependency, and that's JSON server. Alongside that, there's also a db.json file, which has a very simple structure. It's just an object with a single key called products. And inside that, there's an array of product objects. To start this server, I ran a super simple command, npx JSON server, and then I will point my db.json file -port, that means I am mentioning port, and then 8000. So we are pointing to the db.json file and running the server on port 8000 because our main Next.js app will be running on port 3000. Now, since the data has a products node, JSON server automatically created a REST endpoint at /products. So when I hit /products in the browser, I get a full JSON list of all the products. And when I hit /products/1, I get the data for a specific product. Basically, JSON server sets up an entire REST API environment for us automatically. Now, even though this video isn't focused on teaching how servers work, I still wanted to show you this part so you understand the full flow clearly. Now, let's switch over to the Next.js app. I have already started it in a separate terminal. And if we go to the browser, you will see a few options displayed here. We are going to click on this one to explore request memoization. And as you can see, the page content loads, and on the right hand side, we are seeing some logs in the browser. When you are in development mode in Next.js, a lot of the logs that happen on the server are also shown inside the browser itself. This is a super handy feature because you don't have to keep switching to the terminal just to check logs. You can view the server logs directly inside the browser console. Now let's switch over to VS Code and take a look at what's going on in our code. Inside the app folder, all the components are server components. And from there, we are going to open the file located at request memoization/page.js. In this file, you will see right at the top, I am fetching the product data by making a request to an API endpoint. And to handle API requests, I have created a helper function called getData. If you open the file where this helper function lives, you will notice it's a generic function. It takes any API URL as a parameter. There's also a second parameter called caller that's just used to identify who called the getData function because we might be fetching data from different places, a page, a component, or maybe even some custom handler function. Then there's a third parameter called options, which is used to pass fetch configurations like headers, methods, etc. This makes it easier to send custom fetch options from outside the function. Now, what does this helper function do? It performs the fetch, returns a promise, and logs useful information. When the request starts, it logs an entry. Then, when the response comes back, it uses performance.now to calculate the total request duration and logs how long it took in seconds or milliseconds. So overall, nothing too fancy here, just a reusable fetch utility that also gives us useful logging during the request process. Alright, now let's go back to the request memoization page. If you take a closer look, you will notice I am fetching data once at the page level. Then inside Next.js generate metadata function, I am fetching data again from that exact same API. Now the purpose of this function is to generate the page's title, description, and so on. Here, I have just passed a different caller value so the logs clearly show where the fetch was made. But in reality, it's the same API request. From the data fetched in the metadata function, I am taking the names of all Apple products and concatenating them to form the page title. For example, Apple iPhone 16, Apple iPhone 17, whatever's there, it gets added to the title. So up to this point, we have hit the same API endpoint twice on this page. Once inside generate metadata function and once on the main page level. Now, apart from that, this page has three more components: product count, product list, where the product items are rendered using map function, and finally total price component. And you will clearly see these three sections separated in the UI: the product count, the total price, and the full product list. Also, if you look at the product count component, you will see that I have again fetched data from the same API endpoint. This time, I am just taking the length of the data to show how many products there are. Now, in a real-world application, you wouldn't fetch the same data multiple times like this. But for the sake of demonstrating how request memoization works, this example is actually super effective. Also, in my total price component, I have fetched the same data again. So if you count throughout the entire React tree, I have fetched data from the exact same API endpoint 4 times. Once at the page level, once inside generate metadata, once in the product count component, and once in the total price component. Now, just thinking logically, when this page renders, you'd expect it to make 4 separate network requests, right? But here's the interesting part. Since this page is static, meaning it gets pre-rendered at build time, when I run the command npm run build, Next.js will perform all those data fetches during the build process, and we will actually be able to see those fetch logs in the terminal. Let me show you in the terminal. Notice this. As the page is building, the terminal logs show. First, a fetch starts at the page level, fetching product started. Then, inside generate metadata, another fetch starts. Now, the first fetch has a significant network latency, and the one inside generate metadata, this also has some network latency. But they happened very close together, basically concurrently. Then when the product count and total price components start fetching, look at their fetch times. Almost nothing. Why so fast? Because Next.js recognized that the request had already been made, so it didn't fetch again. Instead, it reused the data from the previous request using the request memoization cache. That's the key point here. In Next.js, you can call the same API multiple times freely. Even if your app has 500 components and 300 of them request the same data, Next.js will make just one actual API call and reuse that result everywhere else. This behavior is what Next.js officially calls request deduplication, which simply means no duplicate network requests. You can safely fetch the same API as many times as you want. Next.js will intelligently deduplicate and reuse the response. The biggest advantage here is that we don't need to pass props anymore. You could call this a raw material benefit. Basically, a really awesome bonus. Request memoization doesn't just cache data. It also makes it super easy to share that data across your entire React tree. This innovation from Next.js is seriously amazing because no matter how deeply nested my React tree is, I can fetch the same data wherever I need it. And since I am using the same common data fetching function in multiple places, Next.js automatically deduplicates those requests. That means it fetches the data just once and reuses it wherever needed. Now, there's something else I want to show you. A lot of people think that request memoization only works for static pages or SSG. But that's not true. It works just as well with dynamic SSR pages. To prove that, we will add fetch options with cache no store to our fetch requests. By default, Next.js uses force cache option, which means it caches the data. But when we set it to no store, it becomes a dynamic request, meaning Next.js won't cache the response. I'm going to add this cache no store option in all the places. At the page level, inside generate metadata function, in the product count component, and also in the total price component. Now, when we run npm run build, this page won't be generated as a static page anymore. Instead, it will be an SSR or server-side rendered page. Once the build is complete, you will notice that Next.js shows a lambda icon next to the request memoization page. That means it's now a dynamic SSR page. Every time a user visits it, Next.js will render it on the fly and serve the response. Next, we will start the server using npm start. And when we visit the page, even though we won't see anything in the browser console, we will take a look at the terminal. Take a look closely. You will notice a clear pattern here. The initial requests show higher latency. One has relatively bigger network latency, another has relatively smaller. But both of them has significant network latency. But the ones that follow have much lower latency. Almost nothing. When I turned off the logs and navigated to the home page, then come back to the request memoization page, I saw the same behavior repeating every time. What does that tell us? Yes, it proves that request memoization works not just on static pages, but on dynamic SSR pages as well. The key idea is whenever a page is rendering and the same data is required in the multiple places, Next.js doesn't repeat the request. Instead, it keeps the first request's promise in an in-memory cache and resolves the data from that same promise in all the other places. But remember, this cache is not permanent. It's an in-memory temporary cache. Once the render cycle ends, it gets cleared. For example, you visit a page, data is fetched on the server, then you navigate away. At that point, the cache is wiped. When you come back again, a fresh request is made and a new promise is created. Now, some of you might ask, if the request is only made once, then why do we see higher latency at both the page level and the generate metadata level? Good question. That's because Next.js performs both fetch requests concurrently. In other words, to improve performance, Next.js starts both fetches at the same time. This is called concurrent fetching. So, both spots show some latency. But once the promise is created, after it gets resolved, the rest of the app just receives the result from that resolved promise. And here's the most beautiful part of request memoization. It doesn't store the entire fetch data in memory. Instead, it only caches the promise returned from the fetch call. Why is that smart? Well, imagine you accidentally fetch something with 10,000 records and the entire dataset gets stored in memory. That would cause serious performance issues. That's why Next.js cleverly keeps just the fetch promise in memory. And since once a promise is resolved, anyone awaiting it gets the same result, the same resolved data is shared across the entire tree without triggering extra fetches. That's how request memoization works. I hope now the whole thing is crystal clear to you. Now, let's take a quick summary of everything we have learned so far about request memoization. At the same time, we will answer 6 questions based on the 3W and 3H framework we covered earlier, all related to what we have learned. What we understood from request memoization, let's clearly see it with a diagram. We know that request memoization only works during the rendering phase. And think of it as our request memoization cache storage that lives in server memory during this rendering phase. When a client hits a root, it can happen either at build time or at runtime. But when it hits for the first time, say it hits the fetch products root, naturally, the first time the request memoization will be missed. Then it will go to the data cache or data source. When it hits there, it fetches the data and finally creates a promise, which it saves. That promise may be in pending state or may get fulfilled at any moment. And that very promise will be set in the request memoization layer. Then it responds and the process is done. For any subsequent requests hitting that same root, it will get a hit and the response will come directly from the request memoization layer. This is a simple example how request memoization works. Let's quickly summarize what we saw with the code. Basically, when we render a page, a React tree renders, containing various components at different levels, like you see on the screen. At the top, there's a root layout, then Next.js functions like generate static params, generate static metadata, the layout itself, and inside nested components like component A, B, or any component. At each layer, the same requests can happen repeatedly. For example, at the root layout, requests A and B happen. In generate static params, A and B again happened. In generate static metadata, B and C, and so on. Without request memoization, there would be 15 requests total here. But thanks to request memoization, only 3 requests actually happen. You can imagine how much performance this saves within one render. Another benefit is that we don't need to pass props anymore. We can fetch data at any layer because duplicate requests don't happen. They will just get deduped. Now, let's summarize request memoization by answering questions from the 3W and 3H framework. First question with W. What is it? The answer is, it memorizes identical requests, meaning during a single render pass of a page, it helps remember identical requests so they aren't repeated. The second question is, where does it happen? The answer is definitely on the server side. In server side, in-memory storage. It works both at build time and runtime. For example, when you run npm run build command, it works. And it also works at runtime for SSR pages. Third question, why? The answer is, it prevents request duplication. So the same request isn't made repeatedly. Another benefit is avoiding props drilling, meaning you don't need to pass props around. Now let's move to the H part. That is, how long or the duration. Since this cache lives in memory and we said it lasts only for a single render pass, the cache clears as soon as the page finishes rendering. Next H-related question is how to refresh. Here, there's no need to worry about refreshing because the cache automatically refreshes as soon as the render pass ends. Finally, how to cancel. Do I ever need to cancel request memoization? No. There's no need. It's a very useful feature, and when the first request happens at one layer during page rendering, there's no need to cancel the same request at another layer. That's why Next.js doesn't provide any opt-out or cancel option, and we will never need one. Clear? So I hope with the 3W and 3H framework, we have understood these concepts well. Later, when we study different caching statuses, we will fill out tables answering these questions for each case. This way, without memoizing Next.js caching by heart, you will fully visualize and understand it if you watch the entire video. Before we finish request memoization, I want to share a few important points you must know. First, request memoization is not actually a Next.js feature. It's a React feature. It's included here because without understanding request memoization, we can't fully grasp other caching statuses. Next.js has 3 caching statuses, and one of them comes from React. Second, memoization works only for GET requests. As we saw with fetch, it applies only to data fetching with GET requests, but post, patch, delete requests don't get cached. So clearly, request memoization works only for GET requests. Third, it works only inside the React component tree. That means it applies to components inside your tree and functions like get server-side props or generate static params, etc., etc. Because request memoization happens only during page rendering, which passes through these parts. But it does not work in root handlers or API routes because those live outside the React tree. Clear? The fourth point is, request memoization doesn't work inside Next.js middleware either. Fetch requests inside middleware don't get cached by Next.js, so request memoization doesn't apply there. Keep these 4 points in mind as answers to the 3W and 3H framework questions for request memoization. That's where we will wrap up this part. Next, we will discuss the data cache. Now let's quickly take a look at an example of data cache. On the screen, you will see a menu called data cache, and when you click on it, a new page opens. The URL of this page is /datacache. Let's jump into the code to see how this page is set up. At the top of this page, there's a fetch request to load some data. The only difference here is that we have added a tag to the fetch request. As you know, in Next.js, we can optionally add a tag to a fetch request. That's exactly what I have done here. Other than that, nothing else has changed. It's just a simple fetch request. There are 2 more functions below, but they are currently collapsed. We'll look at those later. In one section of the code, there's a comment saying this page is statically rendered. That's because we are only fetching product data here, and there's no dynamic content. So the page has statically rendered. Now let's get to the main question. What is data cache? Think back for a second. Request memoization says, should I make this request or not? But data cache asks, Do I even need to make an external network call, or is the data already available? And that's the key difference. In this case, when I ran npm run build and hit the URL at build time and created a data cache, that's the cache we are now reading from. Since the page was statically rendered, if I now go to the server folder, open the db.json file, and change the name of Apple iPhone 4 to Apple iPhone 10 and update the price to $899 and save the file. Remember, I have only updated the values on the server. Now, if I go back to the browser and reload the data cache page, it still shows Apple iPhone 4, which means it's still showing stale, outdated data. That's because the fetch request was executed during build time, and the result was saved into the data cache, and it's not fetching the data again now. Clear? Now, if we want to revalidate this fetch data cache, meaning we want the page to fetch updated data from the database again, we can do that in two ways: on-demand revalidation and time-based revalidation. Let's first understand how time-based revalidation works. There's a demo page for this, time-based revalidation demo. When you click a button there, it takes you to the time-based revalidation page, and you will see the data is already updated. Why is that? If you look at the time-based revalidation code file in VS Code, the only difference in the fetch request is one line. We have added the next.revalidate option with a value of 10 seconds. What that means is the page is statically rendered at build time, but it gets refreshed every 10 seconds. If you remember the cold food example from earlier in the video, like a restaurant decides to cook fresh food every 2 hours, similarly here we are telling it rebuild this page every 10 seconds. When the page gets rebuilt, the old data cache is revalidated and replaced with fresh data, and that updated cache is served for the next 10 seconds. That's why if you change the data, say you rename it to Apple iPhone 11, and then reload the page, it won't show the new data right away. It still shows the stale data for up to 10 seconds. After 10 seconds pass and you reload, the new data appears. But if you go back to the earlier data cache page and do a hard reload, the data still doesn't update. That's because that page is completely statically built with Apple iPhone 4 baked in. Alright, so I hope the concept of data cache is clear now. Time-based revalidation means the cache gets invalidated and rebuilt at regular time intervals. What we just saw is how we can make a page refresh itself automatically after a set interval. But in some cases, you might not want the page to revalidate automatically, not at a fixed interval or at some unpredictable time. Instead, you want it to revalidate only when you need it. That means you want to trigger revalidation programmatically. It could be through a button click, or maybe from your CMS where you have a form to edit products, and when you update a product, only then the page should revalidate. In such cases, you can use on-demand revalidation. You can do this using server actions. Remember, earlier I had two functions written and collapsed. One was on-revalidate path action, and the other was on-revalidate tag action. Both of these are server actions. If you are familiar with server actions in Next.js, these are functions you can run on the server. All I am doing is telling Next.js to use its built-in revalidate path function or revalidate tag function. What does revalidate path do? It means you are saying, please revalidate the entire data cache path. So it clears all the data cache for that page and refreshes it. Or if you used a tag in your fetch request, like in our case we added a tag called products, we can revalidate using that tag instead. That's what revalidate tag is for. Both revalidate path and revalidate tag are imported from the next/cache package, and we just call them directly inside our server actions. Now, if we click the revalidate path button, you will see it updates to Apple iPhone 11. And if you reload the page now, you will see the updated data. The same happens if you trigger revalidate tag. So hopefully, it's clear now how we can revalidate a data cache while still keeping the page static. And take a moment to notice, this page is still statically generated. That's what makes it super efficient. Your page stays static until the moment your data changes, and only then it revalidates. For example, you might have a blog site where posts get updated once a year. So you only revalidate when a post changes. Till then, the user always sees the static version. So there's really no need to make your page SSR unnecessarily. Now, the final thing I want to mention is this: the data cache doesn't work only with static pages. You can absolutely use data cache with dynamic pages as well. Let's look at an example of that. If we click on any product card on this page, you will see the URL becomes /datacache/1, meaning this is a dynamic route. If we go to the code, you will notice that inside the data cache folder, I have created a dynamic route. Since we are taking an ID as a parameter here, this is clearly a dynamic page. So this page is rendered with SSR, not at build time. It's generated at runtime whenever a user requests it. And yes, even on this page, you can take advantage of data cache. Let's take a look at what we have done in this page. At the top, we are showing a single product, meaning the specific product the user clicked on. And then below that, we are showing the rest of the products as related products. For example, Apple iPhone 16 Plus. These are listed under the other product section. How did we build this page? First, we fetched all products. So we have an array of all the available items. This is used to display the data in the other product section. And then separately, we fetched just the single product that matches the current ID, which in this case is product number 1. So even though this is a dynamic page, we have still used data cache effectively to reduce redundant fetch calls and improve performance. When I fetch all the products from the API, and since this is a dynamic page, which by default doesn't use any caching, I am explicitly telling it, I want this data to come from a cached API response. To do that, I have set the cache properly to force cache. Along with that, I have also added a tag to the fetch request so that I can revalidate it later if needed. Now, if we go to the browser and scroll to the bottom of the page, you will notice there's a revalidate button placed to allow us to revalidate this page's data manually. That's because we have already cached the API request using force cache. To prove that, I will go to the db.json file and change Apple iPhone 11 to Apple iPhone 7 and save the file. Now, when I reload the page, notice that nothing changes. Even though this is a dynamic page, where normally no cache is used by default, we are still seeing the old cache data. Why is this happening? This is happening because the API request used to fetch the product list was explicitly set to use force cache. Even though the product list is fetched during runtime, since you have manually told it to cache, it's sticking to that cache data. However, the single product fetch still hits the server every time because this is a dynamic page and you haven't set force cache for that specific request. But if you want, you can apply force cache there as well. That means you can use data cache even on dynamic pages. You can use it on static pages, you can revalidate it on demand, and you can even set up automatic time-based revalidation if needed. So hopefully you now realize how powerful Next.js is and how much control it gives you over caching and data fetching. Pretty amazing, right? Alright, now let's quickly understand how data cache works using a simple diagram style explanation. So first of all, this caching happens on the server level. Let's imagine our data cache sits right here. It's a persistent layer and it exists outside the rendering phase. Meaning, by the time we reach data cache, rendering is already happening. So data cache is something that happens after rendering has begun. Now imagine someone hits a root. This triggers the rendering phase. And during this phase, someone hits a URL. If that fetch request is set to force cache, here's what happens. First, hits the request memoization layer. Since it's the first request, it's a miss because this is an in-memory layer. Then it tries the data cache layer. Again, it's a miss since there's no cache data yet. So the request goes to the data source, like your database or API. Once the data comes back from the source, it is first stored in the data cache layer so it can persist beyond this render. Then it's stored in the request memoization layer so other parts of this same render can reuse it. Finally, the client receives the response. For subsequent requests within the same render, data is fetched directly from the request memoization layer. Super fast, no need to refetch or go to the database again. But what if you used cache no store in the fetch request? In that case, first it will miss the request memoization layer, but when it reaches the data cache layer, it won't even try. It's a skip, not a miss, because you explicitly told it not to use any cache. The request goes straight to the data source. Once the data comes back, it's stored only in the request memoization layer and skips the data cache layer completely. Then it's returned to the client. So this is how data cache operates behind the scenes. I walked you through it like this so you can clearly visualize the entire process step by step. Let's quickly take a look at how time-based revalidation flow actually works through a diagram. This also happens entirely on the server side and outside the rendering phase. So here we have our data cache and here we have our data source. Now imagine someone hits a root. If it's an uncached request, meaning the very first request, what happens? Let's say someone makes a request and in the next.revalidate property, we have set it to 60 seconds. So what happens first is it will obviously be a cache miss. Then it hits the data source. Once it fetches the data, it sets the data inside the data cache. And at that moment, the client who made that first uncached request, they get their response. Now, if any subsequent requests come within those 60 seconds, those will be considered cached requests. In that case, we directly serve the data from the data cache. That is, we respond from there. But if someone makes a request after those 60 seconds are over, then that request is no longer cached. It's considered a stale request. This first stale request is what we call stale while revalidate, which means until revalidation completes, the client will be shown the stale data. Now, even though you have called the revalidate function for this stale request, it takes a bit of time to execute. So, during that time, the client will still get the stale data. Once that stale request is responded to, the revalidation continues in the background. After revalidation finishes, it hits the data source again, fetches the updated data, and sets it back to the data cache. From that point on, any incoming requests will again get the data from the updated data cache. And this flow keeps repeating for every user. Now let's quickly take a look at how on-demand revalidation works in the case of data cache. When the first request comes in, meaning the initial request, we make that request with a tag. Let's say the tag is A. This request will hit the data cache, and since it's the first time, it will miss. Then it will hit the data source, fetch the data, return the response, set it in the data cache, and send the response back to the client. After that, all the subsequent requests will get data directly from the data cache. When we call the revalidate function, we actually call the revalidate tag function. At that point, this data cache gets purged, meaning it gets cleared. Later, when a new request comes in, since the cache has been purged, it will miss again. Then it will hit the data source, fetch the data, set it in the cache, and in the next requests, the cache will be hit again. This is how we do the on-demand revalidation process. I have shown you this flow with a diagram so that it becomes easier to understand. Now that we have understood data cache, let's look at the answers to our 3W and 3H questions. The first W is, what is data cache actually? This should already be clear in your mind. Data cache is something that memorizes any fetch request on the server side. In other words, whether your external data source needs to be hit again or not. That decision is taken by data cache. Basically, this cache stores the result of the fetch request, whereas in request memoization, the promise was stored. The second W is, where does data cache live? You already know data cache is persistent, meaning it's long-lived. It's not short-lived like request memoization. Request memoization was only used within a single render pass and then it would be cleared. But data cache is persistent, meaning it stays saved in some storage on the server. It can't be kept in memory, so it stays in the server storage. When you are working on localhost, it stays in the .next folder of your machine. And if you are working on a custom VPS server, it stays on the local disk there. And if you are using Vercel hosting, it automatically gets saved in Vercel's durable edge storage. I am showing you where it stays on your local machine or VPS server. Inside the .next folder, there's the server folder and then your app folder. And inside that, there's a data cache folder where all the data cache gets saved. Clear? I hope you are understanding where data cache lives. Next, our third W is why. Why do we use data cache? You don't really need to memorize this because it simply reduces network calls. In other words, it saves you from hitting an external data source again and again from the server side. If you are using any external server or database, having data cache means fewer requests go there, which keeps those services healthy. As a result, your overall performance improves. The next question is how long? What is the duration or lifespan of data cache? Naturally, we know that data cache is persistent. It works in such a way that even after deployment, if you redeploy your application, your data cache still remains, meaning it persists. Now comes the H questions. How to refresh or revalidate? How do we refresh or revalidate the data cache? You should have this memorized by now. We can do on-demand revalidation, meaning we can revalidate whenever we want. Or we can set time-based revalidation to automatically revalidate after a specific duration. And finally, how do we cancel data cache? If we don't want to use data cache or you don't want any request to apply data cache, then you just set cache no store in your request. For example, just like we used force cache in dynamic pages, in the opposite way, if we use cache no store, that cache will always be bypassed. So basically, you have full control. Revalidate the cache, refresh it, invalidate or cancel it, and if you want, you can completely avoid using cache as well. Next.js has given you all these options. Now that we have understood everything about data cache, let's share a few points related to data cache that you need to know, just like we saw in the case of request memoization. So, data cache is not a feature of React. It's a feature of Next.js. And Next.js is able to do this because it overrides the browser's default fetch API, which is why you are able to use options like next revalidate 0 inside fetch. These options are not available in the built-in fetch function. Next.js overrides the fetch function to implement these features. By intervening here, it ultimately applies its own caching strategy, data cache. That was the first point. The second point is, just like request memoization, data cache also works only for GET requests. It doesn't work for POST, PUT, patch, or delete requests. The third thing is, it's different from request memoization. In request memoization, I told you that it only works inside the React tree and nowhere else. For example, in root handlers, request memoization doesn't work. But data cache works for any fetch request on the server side, even outside rendering. So, if you use it inside root handlers, data cache will still be applied there. But in the case of middleware, the rule is different. No fetch request is cached in Next.js middleware. Always remember this. So in that case, data cache will not be used in middleware at all. And the final point I want to mention, which is very important, is that data cache actually performs differently in dev mode. Many people don't understand this and they end up calling Next.js unpredictable and say a lot of bad things about it. But if you understand this, if you read the Next.js documentation, you will realize that they have done this for your own benefit. In dev mode, dev cache is only used for hot module replacement. And if you do a hard reload, it ignores all the fetch options you have set for data cache and always gives you updated data. Because when you are developing, if you see such case behavior, you might get confused like, hey, I changed the data, but it's not updating. To avoid that confusion, dev mode gives you the option to reload data with a hard reload. And if you don't do a hard reload, to make sure it doesn't have to fetch data again, Next.js internally uses data cache for hot module replacement, or in short, HMR. But in production, it works exactly the way you want it to. So, I hope you will remember these points about data cache and you don't need to memorize any of this because I am taking you through the flow step by step like a storyline. So that was data cache. Now, we will move on to another very important caching strategy, which is full root cache. Since we now understand data caching, grasping the concept of full root cache should be quite simple for us. There's just one extra concept we need to know, and that is the React Server Component Payload. I hope you remember at the beginning of this video, I mentioned that the React Server Component Payload is essentially a process log. When a server component is rendered on the server, it writes down how that rendering happened, like a log file. Later, when the same React tree needs to be rendered on the client, Next.js can use this RSC payload to quickly generate the page on the client side without having to load the entire React library. So now that we understand this concept, let's quickly move on to full root cache. As you can see, there's a link labeled full root cache, and when you click on it, it opens up a page. There's nothing new here, it's just a regular static page. Now think back for a second. When was the first time we talked about full root cache? We asked a question, does Next.js even need to render the page? Meaning, I have entered the server from the client side. Now my job is to render the React tree. But before I even do that, I ask myself, do I even need to render this? Or has some other user already rendered this earlier? Or maybe it was pre-rendered at build time. These questions help us understand that full root cache only works in the case of statically built pages. It doesn't work at all for dynamic pages, because static rendering is only possible when the page has already been generated beforehand. But if it's a dynamic render, the page is generated from scratch every single time, meaning the server creates a new page for each request. So in that case, the question of whether we need to render doesn't even come up. Simply put, full root cache only works for statically generated pages built with Next.js. Let's now take a look at our example. If we dive into the code, inside the full root cache folder, you will find a simple page with a few lines commented. I will explain those in a bit. On this page, I have made a simple fetch request without passing any options. That means this page will be fully statically generated, and we can already see that happening here. On this page, I am displaying 3 Apple products fetched from our product database, and it clearly says this page is statically rendered at build time. Now, if we open the Network tab in Chrome DevTools, clear all the existing network logs, go to the home page and do a hard reload, and then navigate back to the full root cache page, you will notice some new logs appearing in the Network tab. You will see a log entry named full root cache, and then there will be a few more entries like 1_RSC, 2_RSC, etc. These logs appear because in Next.js, when you use a link component and those links are within the viewport, Next.js intelligently preloads those pages from the server in advance, so they are ready even before the user clicks on them. Since the links to the 1, 2, and 3 pages were already in the viewport, Next.js preloaded them. But you can ignore those for now. We are not focusing on them at the moment. Now, if we click on the full root cache item in the Network tab, you will see that its response is actually an RSC payload. In other words, when I visit this page, the server is only sending me this RSC payload file. And using that payload, Next.js is generating the entire React tree on the client side. At the same time, it's using the necessary JavaScript for hydration to fully hydrate the page. Because that tree is already available and Next.js knows which parts are client components, which ones are server components, and how they are connected, so it can generate the full React tree right on the client side. And it's all possible because of this React server component payload. So what we mean by full root cache is this. Whether or not the page will be rendered depends on 2 things. One is the RSC payload and the other is the static HTML part of the page. When you run the npm run build command, Next.js stores both the HTML of the page and the React server component payload in the server's cache. Then, when a user clicks on that page in the production website, only the RSC payload is sent and you get to see the page almost instantly. In this case, the page isn't being rendered again on the server because everything has already been cached ahead of time. And that is what we call full root cache. This was the first layer of caching on the server. If you remember that diagram we saw earlier, you will notice the very first thing that happens on the server is the full root cache. Then comes request memoization, which decides whether the page should be rendered. And then comes the data cache, where it's decided whether to hit the data source or not. So I hope you can now clearly understand what full root cache is. And you have also understood that this only works for static pages. Now, let's see how we can revalidate this full root cache. Just like we revalidated the data cache, we can revalidate this the same way. If we are able to revalidate the data cache, then the full root cache will also get revalidated automatically. Which means here too, you can follow the same strategy: on-demand revalidation and time-based revalidation. Now the question is, if I don't want to use this cache at all, what if I want to opt out of it? The simple answer is you have to make the page dynamic, and there are several ways to do that. In Next.js, you can make a page dynamic in different ways. One way is to explicitly convert the page into a dynamic page. If we go to the data cache folder, you will see that we have a dynamic root created using an ID. When such a dynamic root exists, the page becomes server-side, and naturally the full root cache gets opted out. In the same way, if you want, you can disable full root cache by using any server-side feature of Next.js. For example, if you use the cookies function in the root, Next.js will automatically assume the page is dynamic because cookies are needed at runtime. Similarly, if you use the headers function, the page will also be treated as dynamic and the full root cache will be opted out. Another way is when you use fetch, you can pass the option cache no store. Using this option makes the request dynamic, so the static cache won't apply anymore. Also, while revalidating, you can use revalidate 0. This means every time a request comes in, the page will revalidate, which effectively means it will re-render every time. So it becomes a dynamic page in practice. You can even use this revalidation another way. At the top of the page, just write export constant revalidate is equal to 0. And that's it. This works too. Or even more simply, you can just write export constant dynamic is equal to force dynamic on the page. This will force the page to become dynamic and full root cache won't be used anymore. So we can now understand that full root cache is actually very simple, and the most important part here is the RSC payload. This cache exists so that Next.js can serve statically generated pages really fast. In other words, this cache is only used for performance upgrade. Now let's quickly take a look at how full root cache works using a diagram. First of all, full root cache kicks in during two scenarios: when the page is being built at build time or when a revalidation is happening. During the build time, since the page is static, full root cache is used. Again, when you trigger a revalidation, the page is refreshed on the server, meaning it's built again and full root cache is used then too. Now imagine this, a request comes in for the first time in production. At that moment, there will be nothing inside the full root cache, so it will be a miss. What happens next? If data fetching is required, the app will go to the data source and fetch the data. Then it will generate two things: HTML, RSC payload. Both of these will be generated and stored in the cache. Now the next time you visit the same page, after that initial visit, the first thing that will try to work is the client-side router cache, which we will look at in detail very soon. If that results in a miss, then the second step will be a hit on the full root cache, and the page will be served quickly from there. This flow only works for static routes. But what if it's a dynamic route? In that case, the client-side router cache will miss. And then it will completely skip the full root cache because, as we already said, full root cache doesn't work for dynamic routes. In this case, the page will be rendered every single time, and each time it will freshly fetch the data and generate both the RSC payload and the HTML. But the client-side router cache still gets set and it works in both cases. We will see that in a moment. However, even though we might think of it as the browser's cache, that's not entirely accurate. We will understand this more clearly in the upcoming discussion. I hope you have now reviewed and fully understood the concept of full root cache using the diagram. And now that we have understood it, let's quickly answer the 3W and 3H questions. First question, what? What is this caching strategy? It basically memoizes static pages. That means it stores two things: the HTML of the static page and the payload of the React server component, and keeps them saved somewhere on the server. Second question, where is it stored? It's stored on the server. That's something we have already figured out. For data cache as well, it's stored in the server's local storage. If you want, you can configure a custom storage like an S3 bucket, Redis, or any external location. But in that case, you will have to update the configuration inside the next.config.js file. If you set a custom cache handler there, it will be applied. You can easily check this in the official Next.js documentation. But for now, let me show you where the cache is stored when using local storage. Inside the .next folder, there's a cache folder, and this is where these cache files are kept. Third question, why do we use this cache? The reason is very clear. We know that it helps deliver the HTML and the RSC payload very fast, which helps ensure a fast first contentful paint or FCP of the web page, and that's super important for SEO. Since you are getting a static page, its HTML reaches the client extremely fast. As a result, the browser can display the HTML structure right away and ensure a quick FCP, and Google prioritizes FCP heavily when it comes to SEO. Then, when the RSC payload arrives, the React tree is built on the client side. After that, the required JavaScript loads to hydrate the page. But it all starts with the HTML template being served instantly and FCP getting ensured. And that's where full router cache plays a fantastic role. The next question is, how long does it last? In other words, what's the duration of this cache? Well, it's pretty clear that this is a persistent cache. That means it stays on the server and remains persistent across user requests. So, if you make a request to the server and then I make a request, we are both using the same cache from the same location. It's not like there's one cache for you and a different one for me. No, it's shared. So yes, this is persistent across user requests. And even if you restart the server, this cache doesn't get deleted. It stays. But in the case of data cache, if you restart the server, it gets refreshed. That wouldn't happen with a redeploy though. However, for the full root cache, even if you restart the server, it still remains. It only gets refreshed if you redeploy your app. Meaning, if you redeploy your site on hosting provider, then the full root cache will be refreshed. And along with that, we can also refresh it using any revalidation strategy like on-demand revalidation. Or if I simply make the page dynamic, then that would also take it out of the full root cache system. Basically, if you turn the page into a dynamic page in any way, this cache will be completely bypassed. And finally, one more important thing I must mention. This full root cache is a feature of Next.js. It's not a core feature of React. I hope you now have a clear understanding of how full root cache works. Now, let's move on to the most interesting part, the client-side router cache. Until now, all the caching strategies we discussed were server-side. Now, we will talk about client-side router cache, the one you saw right at the beginning of the diagram. Now let's quickly understand what the client-side router cache actually is. If you remember the very first question we talked about, that was the one where the request hasn't even reached the server yet, meaning you have just clicked on something and now Next.js is asking itself, do I even need to go to the server? At this point, the request is still inside the browser. First, it checks the client-side router cache to see if this page has already been loaded before. If it finds it there, then it won't go to the server at all. You will get the page directly from the browser. That's the very first check Next.js performs, and it does this internally. This entire process happens entirely inside the browser. Let me explain with an example. Look at this web page we are working on. You will see there's a menu item called router cache. And when I click on it, see what happens. A page instantly appears, right? Now, if we look at the code for this, inside the app folder, there's a folder called router cache. Inside that, there's a file named page.js. It's super simple. It just shows some lorem ipsum text. And that's exactly the text you are seeing in the browser. Right below, you will see two links. One says go to static page and the other says go to dynamic page. Now, if we check the code, we are not doing anything complex on this page, right? Which means this page is a statically rendered page, isn't it? Now, inside this page, we have two links. One is a static page link, which takes us to the /static page when clicked, and the other is a dynamic page link, which points to the page.js file inside the dynamic page folder. If we open that page.js file, you will see we didn't really do anything on this dynamic page. We simply used force dynamic to make the page dynamic. So, that means from this client-side router cache page, we are navigating to two different pages. One is a static page and the other is a dynamic page. Now here's the interesting part. Notice that we haven't actually visited either of these pages yet. Let me walk you through it step by step. First, I reload the page from scratch. Then I open Chrome DevTools and clear the network tab history. Now I click the router cache button to land on this page. Pay close attention. Even though I haven't clicked on the static or dynamic page links yet, if you look at the network tab, you will see that Next.js has already fetched both those pages. This is what Next.js refers to as prefetching. It assumes that since those two links are visible in the viewport, you might click on them at any moment. That's why Next.js goes ahead and prefetches them in advance. Super smart. To explain it even more specifically, this behavior actually comes from the Next.js link component itself. This is its default behavior. Notice you haven't passed any special props to it. You have just used a regular link component. And by default, that's exactly how the link behaves. If a link component is visible in the viewport, Next.js will automatically prefetch that route. This applies to both links on the page, and that's why both the static and dynamic pages got prefetched. And since they have already been fetched, when you actually visit the page, you will notice there's no new network request. However, if I now go back and click on the dynamic page, you will see in the network tab, it fetches that page again. Let's break it down. I go back to the previous page, clear the network tab, then go to the dynamic page again, and see, it's fetching that page every single time. Now, if I clear the network tab again, go back to the router cache page, and this time click on the static page. You will see that it doesn't fetch anything new. That means in the case of dynamic pages, Next.js will send a request to the server every single time. So by default, the client-side router cache doesn't apply to dynamic pages. Next.js will always fetch that page no matter what. And what exactly is it fetching? Look closely. It's fetching the React Server Component Payload or RSC Payload. That's the part it's bringing in, because everything else like the layout, static HTML, etc. is already present. Now let's take a deeper look at how we can actually configure this behavior. When we go from the home page to the router cache page, we can see that it's automatically making network calls for the two linked pages. In other words, it's prefetching them. Now, if you don't want that to happen, you simply have to add prefetch is equal to false to the link component. So we will now add prefetch false to both of our link components. As a result, prefetching won't happen anymore. To check that, first I need to rebuild the page in the terminal. So I run build and npm start. Our build is complete and the site is ready. Now we go to the home page, then click on router cache. Notice this time, it did not automatically prefetch the pages. When I click the static page link, only then did it fetch that static page for the first time. Then I go back to router cache and click on the dynamic page. And of course, it loads that as expected. Now, if I go back again to router cache and click on the static page, you will notice it doesn't fetch anything this time, which means the default behavior for static pages is they get cached in the client-side router cache. That's why there's no additional request going to the server anymore. But since a dynamic page always needs to be fetched from the server, Next.js ends up fetching it every single time. You can actually configure this behavior if you want. By default, when you don't specify anything for prefetch, Next.js treats it like this. For static pages, it caches them on the client for up to 5 minutes. For dynamic pages, it sets the cache to 0, meaning it doesn't cache them at all. But if you manually set prefetch is equal to true, you will notice that there are actually 3 possible states. Saying nothing behaves like the default prefetch. Prefetch is equal to false means you want to completely ignore prefetching. Prefetch is equal to true means you are explicitly telling it to prefetch. In this case, the default behavior changes. If you set prefetch is equal to true, the behavior is 5 minutes of cache for static pages and also 5 minutes of cache for dynamic pages. Let's test this now with prefetch is equal to true and rebuild the project using npm run build and npm start. Then we go to the browser and perform a hard reload. Now we go to the router cache page. And look, because of prefetch is equal to true, Next.js has already fetched the page in advance. Now I click on the static page. Nothing happens in the network log. Great. Then I go to the dynamic page, and this time too, there's no network request. Why? Because you explicitly said prefetch is equal to true. Next.js assumes this page is important and you are strongly requesting to prefetch it. As a result, it gives you a bonus. Even though it's a dynamic page, Next.js will avoid making a new request for up to 5 minutes on the client side. Now the question is, can we configure these options even further? Let's say we have set the prefetch options just like before. Now we'll go to the Next.js config file, which is next.js. and add some settings there. First, we will enable Next.js experimental mode. Then we will modify the stale times options. The stale times property itself has two sub-properties, one for static and one for dynamic. By default, static is set to 5 minutes or 300 seconds. Dynamic is set to 0 seconds. That's the default behavior. But we can change these values if we want. Let's say we set static to 10 seconds and dynamic to 5 seconds. Now, if we restart the server by running npm run build and npm start and then open the browser, we will be able to see how easily we can control the cache durations. So, I go to the home page and perform a hard reload. Then navigate to the router cache page. Now notice, since I left prefetch as default, it automatically starts prefetching. I click on the static page and as expected, there's no network request. Then I go back to the router cache page and the dynamic page had already been requested earlier. That's expected. Then I go back to the static page again and this time it didn't wait for 5 minutes. As soon as the 10 seconds were over, it fetched the page again. Done. From this point, you are no longer getting the benefit of the router cache for that static page. This feature came with Next.js 15 and from this point on, every time you visit, the static page will be fetched fresh each time. That means on the first visit, you will get the benefit of this feature. And for the dynamic page, since we set the stale times to 5 seconds, you will initially get a 5-second stale time. After that, it will start fetching the page again on each visit. Now, if you frequently visit a page, Next.js will assume it's no longer keeping it in the router cache. And that's basically the full control mechanism of Next.js client-side router cache. I hope it's now clear this cache stays in the browser's in-memory storage. Naturally, if the user reloads the page, all of this calculation and cache data will be wiped out. That means the duration of this cache is very limited. It only lasts for that particular user session. If we go back to the full root cache diagram we saw earlier, we can also understand how the client-side router cache flow works from there. On the very first visit, the client-side router, which runs in the browser, will always miss because it's session-based. So for that user, the first visit will always result in a miss. Then, as the user navigates through the page, whenever there's a hit in the full root cache or any other layer, the server sends the response and that output is stored in the client-side router cache. So from that point on, it's cached for that user. This behavior applies to static routes, but it also works the same way for dynamic routes. We have already seen that the full root cache always skips dynamic routes, but the client-side router cache doesn't skip them. Even for dynamic routes, it will definitely miss on the first request. But once the server sends a response, it will be stored in the browser's cache for that dynamic route as well. From that point forward, whether it's a static or dynamic page, any subsequent request will hit the browser's in-memory cache and the page will be served from there, just like we saw earlier. Now that we understand the client-side router cache, let's go ahead and answer the 3W and 3H questions. First, what does it do? It helps memoize different segments of our routes on the client side. So when you are navigating between routes, it remembers those segments. Next, where is it stored? It's stored in the client side in memory, meaning it lives inside the browser. Then, why do we use it? So that when we navigate from one route to another, Next.js can prefetch pages faster. It helps with faster transitions by preloading data. What benefit do we get from this? The RSC payload or the React Server Component payload is quickly fetched from the server before you even land on the page. And if you want, you can manually set prefetch is equal to false on any page, and that's totally fine too. In that case, when you click the link, Next.js will immediately fetch that page on demand. Now, how long does it last? By default, for static pages, it lasts 5 minutes. If you are using the default prefetch behavior, for dynamic pages, the default is 0 seconds, so there's no cache retention by default. But if you manually set prefetch is equal to true, then for both static and dynamic pages, the default cache duration becomes 5 minutes. Next comes the question, how do you refresh or revalidate this cache? Well, just like we used to do before, we can still use methods like revalidate by path or tags. which are commonly used for on-demand revalidation. There's another way using the cookie.set method. If you want, you can set or delete a cookie to trigger cache revalidation. And there's one more option. Next.js has a function called router.refresh. Using this function, you can manually refresh the cache. Now, when it comes to canceling or opting out, starting from Next.js 15, page segments are opted out by default, meaning when a page loads, it includes several segments like the layout, loading, and of course, the page segment itself. All of these segments are opted out by default for dynamic pages. As you have already seen, the cache time is already 0 for dynamic pages, so whenever you click it, it fetches a fresh version every time. But for static pages, the fully static ones, they get cached on the client side for 5 minutes. That means the full page, the loading state, the layout, everything gets cached. But in the case of dynamic pages, the page level is completely opted out. So you don't need to manually opt out or cancel anything yourself. I hope by now the concept of the router cache is crystal clear to you. Because we have already explored the entire caching strategy in Next.js in detail, and finally, before ending this video, I have brought you a written resource, actually the best resource, directly from the official Next.js documentation. After watching this video, make sure to check out this link in the video description and go through the caching strategy from the Next.js docs once again. Because as a developer, going through the documentation is a must, and everything I discussed in today's video was mainly based on that documentation. I followed the documentation closely and tried to explain every point clearly in this video. When you go to the beginning of the documentation, you will see a short explanation of what caching in Next.js really is. Then you will notice I followed the exact same order while explaining. First, request memoization, then data cache, then full root cache, and finally router cache. I explained each part using diagrams and code examples to make it easier to understand. And in the same way, the answers to the 3W and 3H questions are also given there. Not just that, you will also find detailed explanations of how to opt out, how to revalidate or invalidate, how on-demand revalidation and time-based revalidation work. Everything is covered in the documentation. But there's one thing I didn't cover in the main discussion, and I would like to quickly show you that now. If you scroll down to the very bottom of the documentation, you will find an API section that lists all the cache-related APIs, such as fetch API, link prefetch, router.refresh, revalidate path, setting cookies, setting headers, and so on. All of these are there in the documentation, and I have used most of them myself in the code. However, the one thing I didn't cover is something called the unstable cache. Now, the name itself might sound confusing because unstable means it's not stable. And as the name suggests, it's not stable and might change in the future. In fact, it's confirmed that this will be replaced by use cache, which hasn't been released yet. So for now, we will continue using unstable cache, but the core concept will remain the same. In this video, I only showed data using the fetch request, but data can also come from a database or any other source. Basically, if you have any request or any operation that takes some time, you can cache that. And if you want to do that, you will need to import unstable cache from the next/cache package and use it. Let's say you have an asynchronous function like getUser that takes the user ID and fetches data from a database such as MySQL, MongoDB, or PostgreSQL. Now, if you want to cache this function, you can't pass fetch options like you do with fetch. Instead, you wrap the entire function inside unstable cache and give it a cache key as a parameter. This will cause the output of the getUser function to be memoized. So, the next time you call getUser, it will serve the data from the cache. The documentation says accessing dynamic data sources such as headers and cookies inside a cached scope is not supported, which means if your function uses headers or cookies, then it can't be cached because dynamic data is not supported in cache. And finally, it also says this API will be replaced with use cache once it's stable. So for now, go ahead and use unstable cache, but eventually it will be replaced by use cache in Next.js, which hasn't arrived yet. In that case, if you want, you can enable the experimental feature and try it out, but I wouldn't recommend doing this in production. Just like we use client or use server, In the same way, you will eventually be able to use the use cache at the file level, component level, or even function level. And anything you do inside that block can be cached. I hope I have made that clear. Definitely take time to read the documentation, because if you want to become an expert in Next.js, if you want to remove the unpredictability of Next.js from your head, if you want to understand the real beauty of Next.js, and if you want to perform well in Next.js related projects or job interviews, you have to go through the documentation. Then understanding Next.js caching strategy is absolutely mandatory. It will make it much easier for you to take architectural caching decisions like a senior developer. So I really hope you will read the documentation thoroughly and carefully. So how did you like today's video? Don't forget to let me know in the comments. If you found it helpful and learned something from me, then don't forget to subscribe to the channel. Also, encourage your friends and colleagues to subscribe as well. That way, all the effort I have put into this video will be worth it, and we will be inspired to create more videos like this in the future. Thank you so much for watching this video and staying with me till the end. I will see you in another conceptual video very soon.